For a long time, it really felt like the global AI story was, well, mostly being written by one side. American tech giants, huge resources, these big groundbreaking models dominating all the headlines. OpenAI, Google, Anthropic, you know the names, always making waves, setting the pace. And Chinese AI efforts often felt like they were playing catch-up, sometimes honestly dismissed as just copying. But then things started to shift. A new player kind of stepped onto the global stage, quietly at first, but with immense impact. Kimi K2 arrived. And this isn't just another model, not just a competitor. This thing from China's Moonshot AI lab, it's like definitive proof. The whole AI landscape, it's fundamentally shifted. China isn't just keeping pace anymore. In some really profound ways, they're now leading.
Welcome to the deep dive. Yeah, today we are really immersing ourselves in one of the most significant developments in AI this year, Kimi K2, from Moonshot AI in China. It's a fascinating story, really.
Right, we've all seen the headlines, heard the buzz around it. But what exactly makes Kimi K2 such a profound game changer? What are the specific, underlying breakthroughs that let it challenge, maybe even redefine, the dominance we've seen from Western models like GPT and Gemini?
Yeah, that's really the core of what we want to explore today. We'll peel back the layers on its, frankly, innovative architecture. We'll dissect how it fundamentally redefines the whole process of AI training. And maybe most importantly, understand why this isn't just a cool technical achievement. This is deeply geopolitical. It really forces us to ask, is the West maybe losing a race it actually started itself?
Okay, so let's start unpacking this. Kimi K2. It isn't just hype. The numbers, the real-world performance metrics are genuinely impressive. It's definitely making waves.
Absolutely. So at its heart, Kimi K2 is built on what's called a mixture of experts architecture, MOE for short. Now, you can imagine it like this vast, specialized council of top-tier experts. And while the model theoretically boasts 1 trillion parameters, which is just an absolutely massive scale in my eye, only a tiny fraction, something like 3.2%, or about 32 billion of those parameters, are actually active at any given moment when it's processing a request.
Okay, so it's kind of like having access to this colossal library, right?
Okay.
Millions of specialized books. But when you ask a specific question, only the most relevant librarians, the real experts for your query, get activated to find the answer efficiently. Is that kind of the idea?
That's a perfect analogy, yeah. And the real power is how those specific librarians, those experts, are intelligently routed to the right request. It minimizes wasted effort. This design lets it tap into this huge breadth of knowledge, but at the same time, stay incredibly nimble and crucially computationally efficient. It's all about smart activation, not just brute force.
And Moonshot AI, the creators, they've actually put out 2 different versions. There's Kimi K2 base, that's more of a foundational model, really designed for researchers, other labs to build on, fine-tune it for specific stuff. Then there's Kimi K2 Instruct. And this one's purpose-built, optimized for what they call agentic chat experiences. So that's more ready to use, aimed at interacting directly with users for complex tasks. And if you look at the benchmarks, Kimi K2 is really standing out. It's widely recognized, especially in the open source world, as maybe the best model out there for coding tasks. In a lot of tests, it even rivals, sometimes beats, some of the top proprietary models. That's significant.
It really is. And its skill and tool use is a particular bright spot that's absolutely critical for these agentic AI tasks we mentioned. When we say tool use, what we mean is its ability to seamlessly integrate and effectively use external tools, link APIs, search engines to get complex jobs done. It's not just spitting out text, it's acting, it's doing things. Plus, it shows genuinely deep knowledge in natural sciences. And here's a real surprise. It got the highest score ever recorded on an emotional intelligence, or EQ, benchmark. So it's not just about understanding language structure, it's about picking up on and responding to the subtleties of human emotion. That's key for more natural interaction.
Right, but it's probably important to clarify something here.
Yeah.
Kimi K2 is often classed as a non-reasoning model. Now, that doesn't mean it's not intelligent. It just achieves its deep thinking, if you like,
Right.
in a fundamentally different way than models like, say, GPT-4o3 or Gemini 2.5 Pro. Those models are designed to explicitly show their work, right? Generate complex, step-by-step chains of thought. Kimi K2 doesn't necessarily reason in that explicit linear way. But its agentic training lets it show these profound problem-solving skills, acting intelligently in real-world scenarios. It's less about showing the work, maybe, and more about just doing the work really effectively. So the key question then is, how does Kimi K2 manage this? How does it get such high performance, shows such deep capabilities while activating only this tiny fraction of its total parameters?
It really comes down to that council of experts MOE approach we talked about. It activates only the relevant specialist, giving it both vast knowledge and high processing speed.
Okay, this is where it gets really interesting for me. Kimi K2 isn't just about impressive performance numbers. It's about challenging, quite directly, the very foundations, the sort of widely accepted rules of modern AI development. It's questioning the playbook.
Exactly. Historically, AI progress has pretty much followed two main scaling laws. First, the pre-training scaling law. Bigger models, trained on more data, get better results. Simple correlation. Powerful. Then there's test time training. This idea suggests that models allowed to think longer, maybe break down problems step by step, tend to produce better outcomes. So reasoning models often use things like chain of thought, reinforcement learning, but usually on problems with clear, verifiable answers, like math or logic puzzles.
Right. But that approach, even though it worked great for structured problems like math, it can hit real limits, especially when you get into more creative stuff for strategic thinking or areas where there just isn't one single right answer. The real world is messy.
Precisely. So Kimi K2, facing these constraints, not being able to just outscale everyone with raw compute power, they chose a completely different path, a novel path. Instead of forcing the model to think longer on abstract math proofs or logic games, Moonshot AI trained it really extensively in these real-world agentic settings, which means it learned by doing, by actively navigating and solving practical, multi-step scenarios.
Like those examples that have been floating around. Planning a whole 3-day trip to Da Nang, right? Finding flights, booking a hotel,
Yeah.
suggesting a detailed itinerary, or taking a Q2 revenue report file, analyzing it, summarizing the key points into a PowerPoint, and then drafting a professional email to management. I mean, these aren't simple questions. They're complex, multi-step tasks needing real-world interaction.
Yes, exactly. And this is crucial. They gathered this truly massive data set, thousands upon thousands of these complex real-world scenarios. Then, by using reinforcement learning on this rich data set, Kimi K2 learned through continuous self-reflection, through experimentation. And critically, it wasn't just rewarded for completing the final task, like booking the flight. It was also rewarded for the efficiency, the logic, the coherence of its entire problem-solving process. How it got there mattered. And the profound result of training like this, you get a model that naturally thinks deeper. Its average token sequence length, basically how much it says in response, is 3 times longer than typical non-reasoning models. It's not being forced to solve abstract puzzles, it's just naturally responding to the inherent complexity, the multi-step nature of real-world problems. This process creates a model that's inherently designed to act, to be a true agent navigating the digital world with purpose. Whoa. I mean, just pause and think about that. Imagine AI systems learning to navigate the world with that kind of nuanced contextual intelligence, not just fetching answers from a database, but actively solving problems, adapting, and maybe even reflecting on their actions. It feels like moving from teaching a robot to solve a math problem to teaching it to genuinely live and problem solve in a messy, unpredictable world. This isn't just about efficiency. It feels like a different kind of intelligence emerging.
That's a really powerful image. It makes you wonder, have we been teaching AI mainly to pass tests, while China's been teaching theirs to, well, thrive in the real world? Is that a fair way to frame it, or am I maybe overstating the philosophical shift here?
No, I honestly don't think you're overstating it. It really does feel like a philosophical shift. And this whole approach also directly challenges what's often called the bitter lesson in AI. That pervasive idea that just raw computational power, just scaling up models bigger and bigger, will always eventually win out over clever algorithmic tricks. Chinese labs, constrained by those significant US GPU sanctions, they simply couldn't play that game. They couldn't compete on raw compute alone. They were forced to innovate somewhere else. And necessity, it really seems, became the mother of invention here. They didn't just scale, they innovated at a really fundamental algorithmic level, specifically with the optimizer. Now, for, over a decade, this technique called AdamW has been the undisputed king, used everywhere in pretty much every leading large language model. But Kimi K2, truly groundbreaking. It's the first really large-scale model to completely ditch AdamW. Instead, it uses a new, pretty sophisticated algorithm called Muon.
Okay, an optimizer, just for our listeners. It's basically the unsung hero working behind the scenes, right? It's the algorithm that helps the AI model update its millions, billions of parameters, constantly adjusting itself to minimize errors during training. So, yeah, this might sound like getting deep in the weeds, but it's absolutely crucial to how a model actually learns and gets better.
Precisely. And Muon, which was proposed by Keller Jordan, it uses something called second-order information. Think of it like this. It's not just knowing if you're going uphill or downhill on a learning curve, but also understanding how steeply that slope is changing. The curvature. This deeper understanding helps the AI training find a smoother, much more stable path to learning. It minimizes errors more precisely, more efficiently. And the real breakthrough is that this kind of stability during training, it's incredibly rare, especially for a model this massive. You just don't often see such a consistently stable loss curve. And that stability allows for much faster, much more effective training in the end.
So, okay, we put all these pieces together, the new optimizer, the stable training, the efficiency. What does this all mean for the bigger picture, for the AI landscape? What's the core takeaway?
Token efficiency, that's the big one. At a level we haven't really seen widely before, Kimi K2 learns significantly more from the same amount of data, and it converges, it learns faster. Get this. It was trained with only 15 trillion tokens. Now, to put that in perspective, that's a tiny fraction of what many Western models of similar size have consumed. And that number, that specific statistic, it really makes you pause and wonder, maybe this fear that we're running out of high-quality training data isn't the whole story. Maybe, just maybe, our current models have simply been incredibly wasteful with the data we have, and China has found a way to squeeze every last drop of insight out of theirs. It's efficiency born from necessity, and it's turning a perceived weakness, those compute constraints, into a pretty formidable strength on the global stage.
You know, I still wrestle with prompt drift myself sometimes when I'm trying to fine-tune models. You know, where the AI kind of subtly veers off track from your original instructions over time. It happens. So this idea of optimizing the very core learning process, making it inherently more stable and efficient, wow, that's not just a technical tweak. It feels like it fundamentally changes what's possible. It's almost mind-bending thinking about the implications for everyday AI users and developers.
It's a profound shift, absolutely. And that MOE architecture we discussed, while it's complex to engineer, complex to manage, it's also a strategic masterstroke when you're facing those compute constraints like the Chinese labs are.
Right. Just to clarify again for everyone listening, a dense transformer model, like an older GPT-3 maybe, it would activate every single one of its parameters for every single token it processes. That's like asking a librarian to read every single book in the entire library just to answer one simple question. Yeah, it's incredibly thorough, sure, but astronomically expensive, computationally, energy-wise, time-wise.
Exactly. Whereas MOE, by contrast, is precisely those specialized librarians. There's this clever routing network inside the model that quickly, efficiently figures out which specific expert or knowledge pathway is best for the task at hand. And only those relevant pathways get activated. So you get access to this absolutely vast pool of knowledge, but at a significantly lower computational cost.
Yeah.
It offers a clear, scalable way to expand knowledge much more efficiently, and that's a key advantage.
Okay, let's refocus this slightly. How does Kimi K2's agentic training approach fundamentally differ from that traditional reasoning model training? What's the core distinction there?
In essence, it trains on complex, messy, real-world scenarios and lots of tool use, rather than focusing on abstract, step-by-step problems like math. It's a profound philosophical difference in approach. Mid-roll sponsor read.
Okay, so we've just peeled back the layers on Kimi K2's really groundbreaking technical side, its efficient architecture, the revolutionary training, the optimization methods. But now it's absolutely crucial we understand that these aren't just, fascinating technical achievements stuck in research papers or labs. This is where those technical shifts spill right onto the global stage. Kimi K2 isn't just an academic curiosity. It's a strategic move. It's a geopolitical shockwave, potentially redefining the whole global AI race.
That's spot on.
Right.
Yeah, moonshot AI's decision to open source Kimi K2. That wasn't random generosity, not at all. It was a deeply strategic move, a calculated maneuver. While we see leading U.S. labs increasingly choosing to close source their models, often, to protect commercial advantages, protect proprietary research, China is consciously and very effectively using open source as a geopolitical tool.
Right. They're essentially neutralizing what's been a major U.S. advantage.
Yeah.
Raw compute power. By releasing a top-tier model like this into the open source community, they're allowing developers, researchers, anyone around the world, really, to build sophisticated stuff, do cutting-edge research, without needing American-owned infrastructure, or, crucially, without needing massive access to those high-end U.S. GPUs that are under export controls.
Precisely. And this strategy, it works on multiple levels. First, it steers global research and development more and more towards Chinese core technology, towards their architectural ideas. Second, it wins goodwill globally. It positions China as promoting collective progress, accessibility, quite a contrast to the closed proprietary approach of many Western firms.
No.
And third, it puts real economic pressure on U.S. proprietary models. Why? Because it offers a free, powerful, and increasingly competitive alternative. Why pay for an API when a comparable, maybe even better model can be run locally for free or very cheaply?
And it's not just moonshot AI doing this in isolation, is it? What we seem to be seeing is this stark contrast between China's synergy, their coordination, and America's often fragmented approach. I mean, consider this. Kimi K2's underlying architecture is remarkably similar, almost identical to DeepSeek V3, another big Chinese model. That really signals deep collaboration, doesn't it? A unified strategic vision across their industry.
Yes, it's a really striking contrast. In China, you see labs like Moonshot AI, DeepSeek, others, often sharing foundational architectures, research findings, even data sets. They seem to operate to a large extent like a cohesive team, driven by national interest, by a long-term strategic vision that's explicitly laid out by their government. Meanwhile, Silicon Valley, well, it's often a different picture. Intense talent wars, fierce competition for market share, very public spats playing out on social media, Musk versus Altman, things like that. And often you see lobbying efforts aimed at shaping regulations to protect existing monopolies. American labs, generally speaking, are primarily fighting for investor profits, for individual market dominance. And that can sometimes hinder collective progress, hinder broader innovation. Not saying one is morally better, but strategically, China's unified front is a very different and potent challenge.
So Kimi K2 is really just the visible tip of this much larger, coordinated iceberg. China's big new generation artificial intelligence development plan. That's not just a policy paper. It actively mobilizes state funding, sets very clear tech priorities, and fosters deep institutional collaboration across companies, universities, government research groups. It's a truly synergistic national ecosystem they're building.
And this flood of powerful, free, open-source models like Kimi K2, it's a huge market disruptor. For countless businesses, for startups, even for entire developing nations, the question becomes pretty simple. Why keep paying for expensive API access to closed proprietary models when a highly capable, maybe even superior open-source alternative can be run locally for a fraction of the cost, or even for free? This really democratizes access to cutting-edge AI. It empowers smaller players, unlocks massive opportunities globally.
But we have to acknowledge this also brings significant social risks. We can't just gloss over those. Uncensored, powerful open source models. They undeniably make it easier for bad actors, easier to generate sophisticated misinformation, create malicious code, engage in other harmful stuff at scale. With open source, a lot of the responsibility for ethical, safe use shifts directly onto the end user. It's definitely a double-edged sword.
Absolutely. So the question becomes, what can the U.S. do in response? Policy shifts are definitely on the table. Maybe escalating export controls, not just on hardware, but on advanced AI software too. Or maybe dramatically increasing federal funding for domestic AI research, trying to accelerate innovation at home. On the corporate side, you might see leading companies double down on their closed models, emphasizing safety, reliability, seamless integration as their value proposition to justify the cost.
Or maybe the U.S. could meet the challenge head on, fight fire with fire, so to speak. That would mean championing, investing heavily in its own open source giants, like Meta's Llama series, really competing vigorously for that global developer community, making sure the open source ecosystem doesn't become totally dominated by Chinese models. It's a strategic choice to be made.
It really brings to mind a lesson from history, doesn't it? Think about the internet. Or GPS. These were groundbreaking American innovations. They started as matters of national security, public investment. Profit was secondary, maybe even irrelevant initially. Then, once they were established, private companies built trillions of dollars of value on top. It's becoming pretty clear which superpower is applying that foundational philosophy to AI development right now. And currently, it doesn't seem to be the United States. So thinking purely from a business angle, how does Kimi K2's open source release fundamentally hit the business models of those big Western AI companies?
Well, it directly disrupts their main revenue streams, doesn't it? By offering this powerful, free alternative to their proprietary paid API access models, it forces them to compete differently. So what does this all truly mean then? Looking ahead, thinking about the future of AI, Kimi K2 feels like a profound shock to the system. It's compelling proof that resource constraints can, kind of paradoxically, drive radical innovation. It directly challenges that deeply ingrained compute will always win philosophy that shaped AI for so long?
Yeah, the message coming from China is unmistakable now. They aren't just catching up, they're actively pushing the frontier forward, reshaping the rules of the game itself. They're turning what many saw as weaknesses, like compute limits, into formidable strengths. And they're cleverly exploiting the strategic cracks, the fragmentation in the West's current approach. The global open source AI ecosystem, it's undeniably being shaped more and more by Chinese models.
This isn't really a subtle shift anymore, is it? The diplodocus, as some called it. It's not an elephant quietly hiding in the room. It's here. It's enormous. It's profoundly influential. And if America continues down its current path, fragmented, mostly profit-focused, the playing field hasn't just tilted a bit. It feels like it has fundamentally, maybe irrevocably shifted.
We really hope this deep dive has given you, our listeners, a much clearer, maybe more nuanced picture of this rapidly evolving AI landscape. It's moving fast.
And this brings us to an important question, something for you to consider maybe long after you finish listening. As AI becomes increasingly powerful, increasingly accessible to everyone, what responsibility do each of us as individuals actually bear in how this transformative technology is developed, deployed, and shaped globally? What kind of AI ecosystem do you ultimately want to see flourish in the years ahead?
It's definitely a question worth pondering.
Thank you so much for joining us for this deep dive. Until next time, keep exploring. Outro music.